Spring JMS. So we're going to take a look at JMS concept a bit first, and then we're going to see how JMS is being supported in Spring Framework. And then we are going to actually see how we can send and receive messages synchronously. Well, JMS and messaging is all about asynchronicity. So sending and receiving messages synchronously is probably not a desirable thing to do, but it is available. So we're gonna actually try that, and then we're gonna actually send and receive messages asynchronously. Okay, and we're going to take a look at message conversion, and then we are going to see transaction as well. Okay, so JMS overview. So what is JMS? JMS is a Java specification that describes a common and standard way for Java applications to create, send, and receive and read messages through a messaging server. Okay. So JMS handles loosely coupled communication between JMS clients. So we use the term clients from the standpoint of clients of messaging server. So sender and receiver, both of them are JMS clients because they are sending and receiving messages through the service of a messaging server. So they are JMS clients as far as messaging server is concerned. So the sender is actually called the message producer, and receiver is called the message consumer. Okay, and the JMS obviously handles asynchronous messaging, and it does also handle reliable messaging. So the reason messaging has been quite popular and still popular is because messaging provides these two critical features. One is asynchronicity, and the second is reliability. So basically, you can send a message to someone else, indicating to the messaging server, I want highest level of reliability, meaning I want this message to be delivered once and only once. I don't want this message to be delivered twice, and I don't want this message to be lost in the middle. So if you need that kind of reliability requirement, then you can actually use a messaging server. So messaging server will make sure the message gets delivered once and only once. And in some cases, you want the messages to be delivered in order, and you can also specify that requirement as well. So if you're not using messaging server, then it's your responsibility to provide that kind of reliability, and that is going to be a lot of code. So typically you are going to use a messaging server to do this asynchronous and reliable messaging delivery. Okay. And JMS doesn't deal with the security services and managing of services. What that means is that these are the domains of the messaging server implementation, meaning vendors will provide these services. Okay, so JMS itself does not address as part of the specification. Okay. So players in a JMS environment. So JMS clients are Java applications that send and receive messages. Okay, so they are called producers and consumers of messages as well. So as I said, they are called the clients because they are clients using services of a messaging server. Okay, so by the way, when I say messaging server, I use the term JMS provider and messaging system. So these are all same things. Okay, and then there are messages. The messages could be text message, map message, byte message. Byte message is used to send binary data. Map message is if you want to send the data in the key value pairs, then you can use a map message. If you want to just send the text, then you can use the text message. Or if you want to send an object, then you can use object message as well. In our lab, we are going to mostly deal with text message. Then there are administered objects. So these are pre-configured JMS objects created by system administrator for the use of JMS clients. Okay, there are two administered objects that need to be configured before you can use the messaging JMS, meaning the messaging server needs to be configured with these things. The first one is a connection factory, and the second thing is a destination. By the way, the destination could be either queue or topic. Okay. The queue is point-to-point model, and topic is publish and subscribe model. Okay, yeah, I don't have I don't have too much time to talk about the difference between point-to-point and publish and subscribe. If you guys have any questions, I can answer later on. But for now, just assume destination could be the queue or topic. Okay, and then there is a JMS provider. So this JMS provider is providing messaging service. Sometimes it's called messaging server or messaging system. These are all servers that are responsible for receiving the message and then sending the message to some place. And typically messaging servers are distributed. They are in the form of distributed systems. So messaging server A is talking to messaging server B, and they are in fact providing messaging service to their clients. So messaging system provides a library that implements JMS specification. So JMS is basically a specification that describes an API. So all the messaging server implementation should actually provide Java library that implement this JMS interfaces, so to speak. So example messaging servers include ActiveMQ. So that is the open source and free messaging server that's available from Apache, and that's what we are going to use. And then there are other messaging servers. Typically, the enterprise server, they come with messaging server functionality. For example, Glassfish comes with its own messaging server, and WebLogic and WebSphere, they also have a messaging server built in. In our hands-on lab, we are going to use a standalone messaging server, which is ActiveMQ. Okay, so exercise 1 is downloading and installing ActiveMQ. So let's do that first. So I'm gonna actually let you guys do these things while I'm actually showing you. Question from Rakesh: what is the difference between JMS and the AMQP? No, JMS is just a Java specification defining Java API. And AMQP is basically, it's actually a protocol. Alright, so let's go to exercise 1. So download ActiveMQ. So if you go to download side of ActiveMQ, there is what is the download? Yeah, so here you go. Download. Oh, okay, where is the download? So yeah, so I should actually go to this page. Yeah, this is let me actually go to download, and I said download. Oh yeah, you have to click this guy. Sorry. Yeah, click the that link, and then you should be able to download so download zip file for Windows and zip file for Unix, Linux, and the Mac. Alright, so once you have downloaded, and you are going to unzip it. You are going to unzip it, and yeah, I think I have 5.11, and you guys are downloading 5.12, but I think it's pretty much the same. So then you should be able to start. So in my case, I have Java Tools Apache. Oh, okay, I don't want to actually want 10. Okay, so I have a 5.11, so I want to actually go to and then go to bin. And if you're running Windows, that is Windows 32 and Windows 64 bit directory. So you have to actually choose one of those. Since I'm running Windows 64, I'm gonna go to Win64. And then you should be able to run ActiveMQ. So let's run ActiveMQ. Okay, so if it is successful, it will just display some messages and launching. Yeah, so this is good. So everything is okay for me. Okay, let's see. And then, yeah, so everything is working fine. Then you should be able to go to admin screen. Okay, so I'm gonna just get this guy because I don't want to lose my lab documentation. So here I'm gonna go to that 8161/admin, and then it's going to ask you the username and password. The username and password should be the admin. Okay, so I specified here admin and admin. Okay. So you type admin, and then you should be able to see this admin screen of ActiveMQ. Okay. All right. So I am going to let you do up to that point. So I'll give you guys about 10 minutes to download it and unzip it, and then start, and then get to the admin screen. Okay, so let's see JMS support in Spring. So Spring provides JMS integration framework that simplifies the use of JMS API with two facilities. So they in fact provide JMS template utility class. So just like it provides JDBC template utility class, right? Same deal for JMS. So they provide JMS template utility class, and that's what we are going to use in our lab. And then it provides message listener containers. Okay. Okay, so Santi, yeah, so the lab exercises are under XML directory, not boot directory. I didn't get a chance to make the Spring Boot generated sample application. So you have to actually import sample applications from the samples XML. Okay, so I'm going to actually show you in a few minutes. JMS template utility class provides helper methods to perform common JMS operations. For example, sending messages, receiving messages synchronously. Again, synchronous messaging receiving is rarely used. Again, the whole purpose of using messaging server is to receive messages asynchronously, right? Okay. Exposing JMS session and messaging producer to the client, to the user, meaning JMS client. Okay, so message listener container. So JMS can be roughly divided into two areas of functionality. So, namely the production and consumption of the messages. So JMS template class is used for message production, and as far as the receiving is concerned, it supports only synchronous message reception. Okay, so asynchronous message reception, Spring provides a built-in message listener containers. Okay, so we're going to actually try JMS template for sending messages, and then synchronous message reception, but the async reception we are going to use message listener containers. Okay, so sending messages. So this is a code. So we have a class called the JMS queue sender. So we are going to have this JMS template object, and then you have a queue. Okay, and then you have to set the connection factory. And connection factory object should be provided to when JMS template object gets created. And then you also have a set queue method, where queue is actually the destination of the message you're sending to. Okay, and this is the code. Here we have a simple send message. Okay, so the way you are going to be able to send messages, you are going to use the send method of JMS template. And then here you provide the queue, that's the destination you're sending this message, and then you're going to create a message. So we are going to just use the message creator class or interface, and then that has the create message, the method, and with the session we are going to just create the text message. Okay, so basically this code, we are going to create hello queue world text message, and then we are sending to this queue. Okay. Okay, now let's see how we can receive messages synchronously. So in order to receive message synchronously, we are going to again use the JMS template class. Okay, so while JMS is typically associated with async processing, it is possible to receive and consume messages synchronously. So basically, you're going to use receive method of JMS template. So until message is available, this receive method will be blocked. Okay, so that's the synchronous model of receiving messages. Okay, so that is what I just talked about. Since during a synchronous receive, the calling thread blocks until message becomes available, meaning the thread that is actually running this receive method of JMS template object will block. And of course, that's not. So it's really rarely used due to this reason, because there is a dangerous operation since the calling thread will be potentially blocked indefinitely. If there is no message, then it will be blocked forever. So you can actually set the receive timeout just to make sure that if there is no message, you want to just get the things timeout. Okay, so that is exercise 2. So we are going to receive messages synchronously. Okay, so let's take a look at the exercise 2. So first of all, we are going to send and receive messages synchronously. So basically what you're going to do is we are going to import the project. So again, the project is the under samples XML directory. Okay, so oops. Let me just create another one. So if you go to labs and if you go to Spring JMS, there are 2 directories and samples.xml. So this is the one that you want to import. Okay, so once you import, you are going to see several sub-project here. Okay, and you are going to run right-click JMS template here. Okay, and you are going to run as Java applications, and then you are going to select Pro. So we are going to actually use producer app under this package. Okay, and then it will send a message. So let's actually try that. So we are going to run as Java application, and so in my case already selected. So in your case, you just type producer to get the main class. Okay, so this is the one, and we select OK, and you should see now it sent 3 messages. Okay, so simple message producer is sending message number 0, message number 1, and message number 2. Okay, so 3 messages have been sent. Okay, now you can take a look at the admin console. So go to the admin console and you should see number of pending messages. So you should actually see queues. Select queues. Okay, now you should actually see the number of pending messages should indicate 3. Okay, all right, so that is what you should see. Okay, so select queue, and this is in fact the name of the queue, my own JPassion queue. Okay, so I'm going to show you how that and you can actually send the messages at the command line. So you can actually go to let's see, I'm going to actually go to the project. So I'm going to go to sync and JMS samples -xml, and go to sync, and I'm going to go to JMS template, and okay, so JMS template. Okay, so that's where I can actually run the code. So I can say Maven -p, so that's a Maven profile, and then I'm going to just copy it and exit as a Java. So here we are going to actually send 3 more messages. Okay, so it sent messages. So now if you actually go to the admin console, now you should, if you refresh the page, you should see 6 messages pending. What it means is on this queue, the messages are queued. Messages are queued on this queue, and nobody actually took it yet. Okay, so because there are no consumers. No consumers took these messages. Okay. All right, so that's basically what you should see. So we see 6 messages, right? Now we're going to actually start the synchronous messaging receiver. So go to consumer app. Okay, so you can go to consumer app, or you can just right click it, and then this time you choose a consumer. Okay, so here JMS template, run as Java application. This time, try to find consumer, so select consumer. Okay, now we start the consumer. So now you can see this consumer in fact received 6 messages. It consumes all the message there is. Okay, so it actually consumes, okay, all 6 messages. Now if you take a look at the the queues here, let's refresh the page. Okay, so this consumer take 5 messages. Okay, so number of pending messages still there with 1, and because number of messages that are dequeued, in fact 5. Okay, yeah, so this is number of in-queued this is a total, and this is the pending message, and this is the total message that have been dequeued from that queue. Okay, so since we have on a single the sender, so now we have a single pending message, and the 5 messages have been dequeued. Okay, so that's what you should see. Now we are going to actually run the consumer at the command line. Okay, so this time we are going to run the consumer at the command line. So here this time it will actually consume the remaining 1 message. Okay, so so it should take the one last message there is. Okay, yeah, I think yes, so receive the JMS message right here. Okay, so now if you take a look at the here and refresh the page, you should see that message is gone, and then the message is dequeued should be 6. Okay, and that is actually number of consumers is 1, right? Okay. Okay, so that is the synchronous. So let's take a look at the code. So if you take a look at the code, we have a consumer app.java and the producer app.java. Okay, and this is a configuration file. Okay, so we basically create the JMS template, and we have a JMS messaging producer, and we have defined the destination, and destination is called the my own JPassion queue, and the connection factory URL is this. Okay, it's just a configuration, and this is the sender code. So this is the one that I showed you in the slide. Basically we are sending message, sending type, and we are just checking if the sending type is JMS send, then we call JMS send messages. Okay, so JMS sending message is this guy, and here we are basically running number of messages like a 3. This number of messages set to 3, so we are sending this message 3 times. Okay, so we create a text message, and then the messages int property is set with the message count. Okay, so message 1, message 2, message 3, that is coming from here, and then we are just sending messages. Okay, so yeah, so this is a case that we are sending producing messages. Okay, and this is a receiver, and receiver has, again, we have configured simple message receiver, and then again same deal with the connection factory, active queue. We are using the my own JPassion queue, and JMS template, and then here we are basically blocking. So JMS just called the receive method, and it just blocks. Okay. Okay, so that is synchronous sender and receiver. Okay, so I'm going to give you guys 10 minutes to do this exercise. Okay, now we are going to receive messages asynchronously. Okay, so these are the steps you can take for receiving messages asynchronously. First of all, you need to implement message listener class. Okay, sometimes this class is called the message driven POJO, MDP. In fact, there are 3 different options for creating MDP. And then you have to configure message listener container. So there are 2 different message listener containers you can choose. Okay, so MDP is configured as a property of message listener container, and then you can start listening. Okay, so MDP acts as async receiver for JMS messages, similar to message-driven being in EJB. Okay, and of course MDB does not require EJB container. Okay, so step number 1. So you have 3 different options. Option 1 is you are going to implement onMessage method of message listening interface. So this is the JMS standard. Okay, and the other 2 options are from Spring Framework. Option number 2, implement onMessage method on the method of the session-aware message listener interface. Okay, so that is from Spring Framework. And option 3 is implement various handle message method of the message delegate interface. Okay, so we're gonna mostly focus on 1 and 2. Option number 1. So here we are going to use a JMS interface of a message listener. Okay, so we have example listener class implementing message listener, and we are basically implemented on message method which receive the message. So in our code we just check whether message is the text message type, and if it is, we just display it. Okay, so we're not doing anything fancy, we're going to just display it. Okay. Option 2, so use it if you want MDPs to be able to respond any received messages using sessions applied on message. Yeah, so if you want to take advantage of session object that gets passed on, then you can actually use this. So in this case, the reason you might want to actually use this one is that you might want to use that session to create another text message and then exchange. So these things could have it happening within the context of a session. Okay. So if you want to introduce the concept of a session for your exchange of messages, then you could use this session-aware message listener. Otherwise, it is the same with the first option. This is the allows you to expose almost any class in MDP, so it gives you a bit more fine-grained control. Okay. All right, so step number 2, now we need to configure message listener container. So what is a message listener container? It's basically intermediary between the MDP and messaging provider. So basically, taking care of the registration of registering to receive messages and participating in transactions and resource acquisition and release, exception conversion. So all the chores, low-level plumbing work will be performed by message listener container. Okay. So basically, by using message listener container, you can just focus on business logic rather than dealing with all this low-level plumbing work. Okay. In fact, Spring provides 2 message listener container implementation classes: simple message listener container and default message listener container. The difference is that the default message listener container is the default, and that is in fact used in most cases. The thing is that default message listener container allows dynamic adaptation to runtime demands and will be able to participate in externally managed transactions. So I think there was a question about the transaction participation of the messaging server. So if you are using default message listener container, then it could actually participate in distributed transactions through JTA transaction manager. Okay. The simple message listener container does not support transaction, and it is configured with a fixed number of JMS sessions. Okay, so even if you have a lot more messages coming in, it's not going to actually increase the JMS sessions. Okay, so this is probably mostly for testing purpose. Okay, so typically you are going to use a default message listener, which is adapting to the demands, workloads, and also it can participate in the distributed transaction. Okay, so now you have decided to choose which one to use, right? Then you need to configure that message listener container. Okay, so message listener container need to be configured with the connection factory and destination, and then message driven POJO. So that's the code that you are going to write, right? And then transaction. So if you want to have your messaging to be participating in a transaction, then you have to, you have to use the default message container. Default message listener container. Okay, so this is an example. So we have created message receiver. This is our own, message-driven poser class. And then we are going to configure, so in this case, we are configuring simple message listener container. So in this case, we still need the connection factory and queue and then message receiver, which is this guy. Okay. And this is the default message listener container configuration. So again, we provided our MDP class that is specified here. And then in terms of message container, listener container, we are using default message listener container object. Okay. Again, connection factory and destination should be set. And then the default container configuration with the JMS name, let's see. Oh, so you can also specify the concurrency. So this is the number of sessions that they can, handle. So it will actually start with a 5, and then it could actually increase to 10. So it could dynamically changing the number of sessions. Okay. All right, so that is the configuration, and then you should be able to listen asynchronously. Okay. All right, so let's take a look at the exercise 3. We are going to just do exercise 3. Okay, so we are going to run the message listener class, and that is a consume app. So that's what you are going to run. Okay, so here we are going to run the message listener. So right click, run as, and Java application, and consumer app, run it. Okay. Okay, so now it is actually running and is waiting. Okay, it's not actually it is waiting, right? Okay, but it's not synchronous receiver, it's like asynchronous receiver. Okay, so let's say verify that there are 5 consumers waiting for the messages. Oh, okay, so we can actually check how many consumers are in fact up and running. So let's refresh the page. Okay, now we have the one that we were using here is this guy. So my own JPassion async. Yeah, so this is a sync queue, and this is async queue. So we have a number of consumers are 5. Okay, so on this queue, there are 5 consumers who have registered, and they are waiting asynchronously. Okay, all right, so that is that. And now we are going to send a message, from the message listener. We are going to actually send the producer. Okay, so here we are going to run as and Java app, and this time we are going to run producer. So this producer will send messages to async queue. Okay, so choose this guy, and okay, and let's see how many messages he sent. Okay, so he sent just 3 messages as well. Okay, so now what you should be able to see is that you should see in the console of if you go to the console of the what is the console? Maven console. Yeah, I'm actually looking at the so I should actually see the console of consume. Oh, you know what? I should actually the same console message here. What is the stupid? Okay, so here you go, the consumer. So when so consumer, I should actually see these 3 messages received. Okay, so this is the consumer that is still running. Okay, all right, and now if you take a look at the here, you should actually see refresh the page. So you see the messages in queued. The 3 messages have been in queued and 3 messages dequeued. Okay, all right. Okay, so that is that, and if you take a look at the code here, this is pretty much what I showed you, okay, in the code. So in this case, this is our code. The message listener interface, we are just using JMS message listener interface, and then we are basically implementing log message, and only thing we do is basically log it. So that's basically what we are saying here. This is an info log, right? Okay. So that is the exercise 3, and exercise 4, session aware listening. If you run it, and then so my own session, my own Q3, and then you're gonna produce. So in this case, we are actually sending messages and we receive messages right away, okay, because it's actually using the session to send the message back to the sender. Okay, so let's actually try this. Session aware messaging. So session aware messaging listener. So we are going to run as, and Java application. Again, let's consume. We're gonna actually run the async listener first. Okay, so now it's running, and then we are going to run as Java application, this time sender producer, meaning. So we are going to produce, and then we are going to see, basically you can see it sent a message, and then it received a message, okay, from the receiver. Okay, so it's the message is just responded back. Okay, so that is the code that I showed you. So you can certainly take a look at this, and receive receive the message. Basically the create the text message and the create producer. So basically we are basically creating the producer from the same session, and then just responds back. Okay, so in this case we don't have to actually specify any queue, anything like that, because it is in the same session, right? So it knows which queue it's dealing with. You see what I'm saying? So if this guy is not, if he's not using session, then this guy need to actually specify, what is the name of the queue and all that stuff. Okay. All right. That is pretty much that. Let me actually finish up the presentation. Message conversion. So in order to facilitate, in order to facilitate sending domain model object instead of JMS messages, JMS template has a various send method to take advantage that take the Java object as an argument, and then it will convert into the messaging type that JMS understands. Okay, so convert and send and receive and convert. So utility, these are all utility methods that convert the Java object to JMS messages and vice versa. Okay. So this is the case. So here we are going to convert and send. So we have a Java object. We have let's see, the map, new message, post processor. So the modify the message header and property after the map is converted to a map message. Okay, so in this case we are basically convert the map object, and then we are actually setting a message header. Okay, so this is actually called after message is actually created. Okay, so hash map, and we are just sending map. So this is the one that gets converted, and then once it's converted, then we can even set the int property and the JMS correlation ID. So these are the fields of JMS messages. Okay. Let's see the result of customized message. So so this is the representation of the message that got created. Okay, so basically we got a map object, and we are actually creating a map message, and then we can even set the values of those the header and so these are header and properties. These are in fact the JMS header structure. Okay, so we set the correlation ID and count ID kind of things. Okay, so that is a message conversion exercise 5. And transaction, in order to actually have the transaction to be supported, you have to use the default message listener container, and session transacted true. So this is actually local resource transaction, And for the distributed transaction, you have to actually specify JTA transaction manager. Okay, and you have to configure that the JTA transaction manager object to your default message listener container. Okay. Okay, so I feel like I rushed a little bit. So that's the end of the presentation. We have 6 minutes, so I'm going to let you do exercise 4. Okay.